All right, in this lesson 3.2, we're going to talk about the multiplication property of equality. It's very similar to the addition property of equality. And this is the fancy way to write it. If you have A, B, and C and they represent numbers, as long as C doesn't equal 0, because we know we cannot divide by 0. If A equals B, then if you have an equation where A equals B, you can multiply both sides of the equation by the same number. Okay? And you can divide the equation by the same number, which is, in this lesson, you'll see it as multiplying it by the fraction, and you'll understand what I'm talking about here in just a minute. So in other words, both sides of an equation may be multiplied or divided by the same non-zero number without changing the solution of the equation. Whatever you do to one side, you have to do to the other to keep it equal, to keep it fair, to keep everybody happy. So I'm going to show you some examples. Here, if you have an equation that says 12 times x equals 1,440. Well, I need my variable by itself. And in order to get it by itself, this time I need to multiply it by its reciprocal, because that will turn it into 1, and that way my x will be by itself. Well, if I multiply it by its reciprocal, I have to do the same thing to the other side. And yes, I'm writing it like a fraction, but you can also show it as division if you want to. This is the same thing as 12 divided by 12, and 1,440 divided by 12. You could write it both ways, and you'll see why I'm writing it this way when we get actual fractions. It's easier to see it this way. So that now I just have 1 times x, and I just wrote this just to show you that 1/12 times x really does equal 1. It's really there, just we don't always show it. So when I multiply this side by 1/12, I get 120. So when I check it, I substitute 120 in for my x, you'll see that it does equal 1,440. Here's another example. This one simply says negative x equals 9. Well, we know that this is like a 1 right here, correct? So in order to turn this into a 1, a negative 1, I need to multiply it by negative 1, because negative 1 times negative 1 turns into a positive 1. And when I do that, I need to multiply the other side by negative 1 as well. Keep it fair, keep everybody happy, since it's equal. So now x times 1, and that's just there just to help you see that it really is there. It's not, usually we don't show it all the time, but it is there. X equals negative 9, because 9 times negative 1 is negative 9. And if you put negative 9 in for x, you'll see that the opposite of negative 9 is 9. So it does check and balance our equation. Now here is why I've been writing them as fractions, because if you come upon a fraction, it will help you see really in essence what you're doing. So this equation says 3/8 equals negative 5/4 x. Well, I want my x by itself, so I need to multiply this by its reciprocal, and its reciprocal is negative 4/5, because I need to turn it into 1. I need to get just that x by itself. Well, if I do it to the right hand side, I need to do it to the left hand side, so everybody's happy and all is fair and nobody's complaining. So when I multiply the left hand side by negative 4/5, I get negative 1240 over 40, equals x, and that can reduce down to negative 3/10. And like always, I can check that very quickly by putting negative 3/10 in for x right here. And when I do that and multiply it all out and reduce it, I see that it does equal 3/8. Voila! Here's another example, and another reason why I'm showing you this as multiplying by the reciprocal fraction instead of just dividing. You might see an equation that says y over 9 equals 14. Now we know we can write this, hopefully you remember, as 1/9 times y equals 14. Now when I write it this way, it will help you see when I need to get my variable by itself, I need to multiply the 1/9 by its reciprocal, which is 9. And if I multiply the left by 9, you better believe I've got to multiply the right by 9. So when I do that over here now, since we've multiplied by reciprocals, we get just y by itself because it turns into 1. And 14 times 9 is 126. And I showed you over here that instead of pulling out the 1/9 y and showing you that this is what it equals, I could just say, since I know that in my head, I could just say 9 times 1/9, and that's going to, those two 9s are going to become 1 because this is actually 1/9 times 9. You don't have to write it this way unless it helps you see what you are doing, and then that's perfectly fine. Over here is just a quicker way that you can write it. And of course, as always, you can check it and put in 126 and divide it by 9 and see if you get 14, and you should, to make sure you got it correct. As always, you might see some word problems where we'll have to do this and do the multiplication property of equality. We've got Penny bought a 12-bottle case of juice on sale for $6.72. What was the price of each bottle? Well, she bought 12 bottles, but we don't know how much they each cost, so I assigned that X. But I know that all 12 of them equals $6.72. Well, to get 12 by itself, I can multiply by 1/12, or I could say I'm dividing by 12, which is the same thing. And when I do that, I forgot to show you that I did this to the other side of the equation, and I don't have my pen, so pardon me as I try to draw this with the mouse. So I'm actually multiplying this by 1/12 or dividing by 12, whichever one you want to say. There we go, that looks better. Now, when you divide that by 12, you get the cost of each bottle as being 56 cents. Ha! So, that is your example of word problem, and that is all for today. So, we will be practicing using the multiplication of property of equality in solving some equations very soon. Thank you.